Good afternoon, ladies and gentlemen. I'm here to give you a brief talk about the Strathclyde Space Institute, and in particular, I would like to introduce a bit more about Space Mechatronic System Technology Lab, which I run. Works. Right, Strathclyde Space Institute is probably one of the largest, biggest space engineering research institute in Europe. We have a number of centers here. In the middle, essentially, we start with the Advanced Space Concept Lab, funded by Professor Colin McGuinness. We also have a Center for Future Transportation System led by Professor Richard Brown. I run a Space Mechatronic System Technology Lab, and we also have satellite application centers. It's worthwhile to also highlight we have a Scottish Space School as an outreach activity unit. Each year we attract probably 200 students at the age of 16 to 18 years old to come to Strathclyde to inspire them to study engineering and try to create or attract more talented younger generations to study engineering. Malcolm has already mentioned the satellite Catapult Center of Excellency, so I'm not going to say anything on that. There's another few centers associated with this Strathclyde Space Institute, which covers some signal processing, etc. So we really cover a whole spectrum range of upstream technologies. The scope of SMAS Tech, or Mechatronic System Technology area, covers this broadly 6 areas. We do orbital space robotics for orbital servicing, in particular for satellite refueling and other type of services. And this is based on the model-based decision-making technology, robotic operation planning, and vision-based systems as well. The second area we also work on is the mechatronic system development methodologies. I think people tend to focus on particular technology development. We try to step a bit back and try to identify and investigate what would be the most effective and useful methodology people could use to help them to develop the space system. And the modular design methodology, design for life cycle methodologies, these are some of the examples we have developed. We also work on the modeling simulation platform development for mechatronic systems, and we develop a couple of these such systems. The area we also look at focusing on the function modeling for mechatronic systems. We develop a few software systems which can help engineers, designers to come up with a more creative, innovative design concept. Another area we look at is the design for manufacture. So well you can create models, CAD models, etc. But how to make sure the product you design can actually be manufactured. We look at various techniques to ensure its manufacturability. The final area is about novel and innovative mechanism devices, etc. The bottom of the image shows a universal spacecraft connector. Some of my PhD students are working on to develop a connector which enables the transmission of energy, signals, loadings, etc. That's one example of some of these novel devices we develop. We have about over 20 researchers working in the lab, consisting of 4 academic staff and the various of postdoc researchers and PhD students working in broad 6 areas I mentioned earlier. Let's give you some flavor of the projects we are running currently. So we have received funding from STFC on an agri-tech project working on the space application or space technology application in agriculture applications, and it covers 2 areas. One is the robotic, autonomous robotic rover system. The other area is try to use the space technology, try to identify the soil quality of the aspect. The other aspect of work I also do is work with the food industry, run a project called Smart and Flexible High-Value Cake Manufacturing. Cake manufacturing may sound not nothing to do with the space, but in fact, the handling of softer, sloppy materials is extremely challenging, and we have learned a lot of things, and we feel that can be applied in some of the space debris captures and other type of applications in this area. Recently, we also received funding from the UK Space Agency to develop an agri-rover. Again, it's the use of space technology in agriculture application, and I'll give you probably a bit more details of this later on. This is a list of facilities we have in the 2 laboratories I have in the university. We have 3 Strawberry robots, concurrent design, 3 stereoscopic CAD design modeling facility, and the picture there, so we'll get there. It's a back-off controller which is capable of controlling up to 1 solid individual joints or individual robotic joints type of application. We also have haptic devices there which has been used to control the space robotics haptically. And we also have various of scanning devices with the accuracy of 2 microns to use for the space structure measurement, structure monitoring, and use some of these to help to analyze the structural stability, etc. This particular project on AgriBot is aimed to develop an intelligent and lightweight agri-robot which can be used for a number of applications. The key application is try to detect the soil quality in terms of nitrogen, the nutrients of the crops required, and it also uses various of image-based sensing technology, range finders, laser, ultrasonic lasers, etc., to autonomously guide the rover to undertake a particular soil quality sensing job. And the key aspect to this is the whole range of sensors used in this rover, which include ultrasonic sensors to detect any potential objects, and gyroscope to get orientations information, and other type of sensors. So we have a whole range of sensors working in collaboration, which will autonomously guide the rover from starting points to the end point, and try to undertake all the sensing job and any other required interventions like fertilizer, sprayings, etc. in our process. So that's all my presentation. Quick overview of what we do. If you're interested in any of the aspects of the work we do, we'll be quite pleased to talk to you. Thank you very much.